Testing. Hello. I think I see a few people here already. It's always great to have a sanity check and someone let me know in the chat if you can hear me or not. That'd be great. Also, as we're waiting, because we're a few minutes early or a couple minutes early, let me know in the chat how you're doing, why you're interested maybe in ML monitoring or AI observability. If you're working on anything cool, generally it's always just really cool to kind of see like where people are watching from and what you're working on. Thank you, Rock, for letting me know that you can hear me. Always good. I always assume people can, but it's always great to verify. Are you working on anything interesting? And we're going to wait a few minutes before we get into the content. So again, anyone joining, put in the chat, what you're working on, maybe where you're watching from. It's really fun getting to know the people watching. Also, for you as the attendee, I think it's really fun. Anytime I go to an event anyway, I know it's always really fun to kind of see who else is there with me. And if you don't have a work project to talk about, I'm always open to hearing about, movie or TV show recommendations. Again, I see people joining in. We're just waiting a few minutes to get started as people keep trickling in. Let me know in the chat where you're watching from, if you're working on anything interesting. And I'm just going to make sure all the live streams are going. Did everyone have a good week so far? You can just say yes or no to that. Also, I'll just mention as people are joining in that there's a Slack channel you can join if you want to stay connected. It's a great place to ask me questions later, ask other people in the industry questions, as well as stay connected with each other. I'm going to post some links in the chat. I know last time they got kind of clumped together. I'm going to try to space it out. But basically, all the links I'm going to bring up or that I can anticipate I'm going to bring up are in the description. So if you're watching on YouTube, you can just scroll down and click on the links below, as well as I'm streaming to LinkedIn, and they might not be clickable, but they should be in the details, and you should be able to copy from there. Someone said, hello from sunny but smoky Seattle. At least it's clearing up. At least it's not as smoky as it was. And we'll wait just another minute or two before we get into some of the content. Yeah, looks like the links there in the chat didn't work out well. So definitely just click them in the description. That's going to have everything that we're going to need for our workshop today. And I'll share them again in a second. But I'll just share just the Slack channel I was talking about if you want to stay connected there. Just this link should work fine. If not, again, it's in the description below. Someone said, hello from Colombia. Awesome. Thank you again. Thank you for typing in the chat as well. I think it makes it way more fun for me getting to know some of the people watching. And then I'll get to the slides in a second, and we'll bring this up again. For setup, though, you'll just need to have a Google account. We're going to use a Google Colab notebook. If you've never used that before, don't worry. I'll go over it when we get to it. But then the only other thing you'll want to do or make sure you have set up is a YLabs account. You can sign up for free here. And again, the link is in the description, but I also just posted it in the chat as well. So those are the two things you only really need, is a Google account, which I'm assuming most people have, and then a YLabs account. And I think we're going to go ahead and get started. Again, feel free to type in the chat as I go. I might not see your question right away. I'll try to get to it, and if I don't get to it during the stream, we can message about it on Slack. And then also feel free to answer other people's questions in the Slack, as well as connect with people. Sorry, in the channel is what I meant to say. So it's always really fun, at least for me, when I go to live workshops, if there's discussion happening as an attendee or the presenter. So I'll go ahead and present our slides that we're going to get started with. This is Intro to AI Observability. We're going to be covering monitoring ML models and data in production. And just real quick, what this workshop is, this is hopefully a super friendly introduction to AI observability with no previous experience is expected, but knowing some Python and machine learning concepts could be helpful as we go, because we will be using Python and machine learning. This is going to be a workshop, so there's going to be some slides that I'm going to go over just some high-level theory and concepts with, and then we're going to go into code and actually use a tool to look at our models and data. So again, like I said, we're going to cover some high-level concepts, and then we're going to implement it in a Colab notebook. And just keep in mind, you can't learn everything in an hour. The AI observability field is quite big, so an hour, cramming everything to an hour probably wouldn't be possible. But my hope is that, if you've never done any ML monitoring before, you could come to this workshop, understand at a high level the concepts, and then actually know how to implement it. And I think if you stick around for the hour, no matter your experience before coming into it, you'll have a lot of fun and hopefully learn some new things. And parts of this could feel fast-paced or challenging depending on your experience. Just keep in mind that that's totally okay. And obviously, it's important to keep learning after this workshop. So I'll stick around and I'll point you to some resources afterwards as well. A quick introduction. My name is Sage Elliott. I'm a machine learning and MLOps evangelist at YLabs. We create some really cool tools, which you'll see some of today, around AI observability and ML monitoring. For about the last decade, I've worked in software or hardware, mostly with startups and a couple consulting agencies in Seattle and Central Florida. And I really love making things with technology, and sometimes something I'm working on, but during talks and presentations, I tend to talk really fast. So I do apologize if I am talking pretty fast. But that means we get to get through a lot in the hour that we have. About you, I'd love to hear, where are you watching from? Why are you interested in ML monitoring? And then again, the link to the Slack channel is in the description if you want to join the Slack and stay connected. You can also introduce yourself there to more industry professionals. So I'm going to pause for a second, take a drink of water, and I'd love it if you want to type in the chat, whether you're watching on YouTube or LinkedIn, where you're watching from at the bare minimum. And we already had one person from Seattle, from Columbia. I'm streaming from Seattle. Someone said YouTube. You are watching it on YouTube. That is fair. But I meant, where are you watching it? As in, where you're located while you're streaming. Someone said NYC. Building ML ops workflows. Very cool. Awesome. You can feel free to keep typing in the chat. I'm going to move away from the slide, but if you haven't introduced yourself, I definitely recommend that you do. And again, Slack channel if you want to introduce yourself in there and stay connected with people for longer than just this workshop. Again, setup just for people joining right now is you'll want to have a Google account, and then you'll want to sign up for a free YLabs account. Again, this is in the description, so you can click on it there. There's no card required or anything. It's very easy to sign up. And those are the 2 accounts we're going to need to complete the whole workshop today. Someone said, hello from Canada. Welcome. All right, so what is AI observability? Well, AI observability is the collection of statistics, performance data, and metrics from typically kind of every part of the ML system, or at least it should be. And then you should deliver, some sort of actionable insight from all that data that you're collecting to various stakeholders, right? So some people think it's just one person a team, but often it's multiple teams or across multiple teams. So this might be a little bit small as I'm presenting, but basically over here, we just have some examples of a production environment, such as running live inference, batch inference, offline training and testing, your feature store. And then you would use some sort of tool to collect AI telemetry. And today we're going to use an open source tool called YLogs. And then we want to be able to send that data that we're collecting into some sort of observatory platform, and then take actions based on that. And that could be, anomaly detection, and then triggering something in our ML pipeline. It could be just providing the visualizations and having people look at them, and kind of work backwards of figuring out why why are you having an anomaly, or why did things change over time. And then also, instead of just triggering pipeline, right, you might actually just send alerts like an email or a Slack or something, and then you want to go investigate what's going on with your ML and data systems. Why is it important? We have a shirt that says bad things happen to good models. So there's a lot of things that can happen, once you even train your model and deploy it, and it passes all your tests, your validation test looks great. Things happen when you deploy models to real world, including data quality, data drift, model drift, and you might have some sort of bias in your model. And a lot of this can happen in multiple places in the pipeline, or at least data quality can. So if you're doing any sort of transformations or anything with your data at various steps, you have a potential for failure. And so we'll talk a little bit about why data quality problems arise and why data and model drift might arise. But I also love hearing from your experience. It's way more fun if people talk about things they've seen. Obviously, don't give away any sensitive information or anything like that. But if you want to put in the chat, like a data quality issue you've seen, or an example where data drifted and how you tackle that, it's always really valuable to hear about how other people handled it. So data quality, like I mentioned before, if you're not careful, poor data quality can cause your pipeline and models to fail in production, which is not only undesirable, but can often be pretty expensive. Some examples is an input sensor's damage or causing bad data. Data was manually entered incorrectly. A camera is pointed in the wrong direction. That would be like if you're using something with computer vision. Schema changes, so a library or software package updated something, and you didn't know about it, and now the data looks different. And pipeline bugs basically anywhere. Does anyone have an example of data quality kind of failures they've seen in the field that they want to share? Someone said, to bypass data drift, some team members just retrain every day, costing money. That sounds like it would be pretty expensive. Plus, you have to have, if you're retraining every day, I assume you're collecting data and labeling the data every day. And if you are labeling data every day and you're not monitoring for any drift or unique values, that would be a lot of money. I could see like monitoring for uniqueness, kind of like monitoring for drift and then labeling that and then retrain your model. But that does sound really expensive. Oh, one example of data quality I was going to bring up, how I got my start in machine learning and computer vision was building some manufacturer QA testing with an edge device and a camera. And something I always see in manufacturing floors is light changes. So I would have, a light go out or something like that in the manufacturing floor, and now my images were too dark to actually do any detection on. So that'd be an example of like the input sensor it wasn't damaged in that case, but that was directly at the input source. data drift. Input for predictions are no longer as close to the original training data as kind of like how I'd like to think of it. So this is where your data coming in, once you have a model deployed, the data that you're now making predictions on, doesn't really match what the model learned. And now it's probably not making very good predictions on it anymore. So a couple examples could be seasonality changes. This could be that, if you trained your data on purchasing habits for customers in the summer versus around the holidays in December, their buying patterns could have changed. And then again, because I have a background in computer vision, but also because I think, humans are pretty visual people, it's easy to think about seasonality changes from a image standpoint, where if you had an animal that was on green grass and then you train a model, and then in the winter they're standing on white snow, chances are that model wouldn't perform as well because it doesn't really match what it learned. You might have a new group of users. So if you're training on voices and all of your voice input was adults, and then it became kids, and that's like a pretty big shift in tone. Consumer preferences have changed. And again, what examples have you seen? If anyone wants to share an example of data drift in the real world that they've seen, that would be cool. But basically, that's the input data is changing, and we're not getting accurate predictions probably anymore. So we can monitor for this by looking at the data, right, and seeing how it's changing over time. And so, like someone mentioned, they get to bypass data drift, some team members just retrain every day, which I think is crazy. Model drift, the incoming data didn't change, but the output no longer matches. So now, our input data is fine or hasn't changed much, but the trained model piece that's deployed isn't really making the predicted outcomes that we want. And this happens if there's, like the model just doesn't really map to the values in the world anymore. One example I like to bring up a lot is the housing market. So if you had a really simple model that was just taking, number of rooms and square footage, that data doesn't change anymore, right? Like, let's say houses, they weren't adding more to it, but houses now are more expensive than they were 20 years ago. So if you had a model trained on data from 20 years ago and you're still using that same data, the prices wouldn't be correct. So in that case, the model just isn't really mapped to the values that are reflected in the world today. So the data didn't change, but the, houses are worth more now. And COVID-19 is a good example of a lot of stuff changed on the data drift side, as well as the model drift, where people's behaviors changed, but also just like the price of everything went up. And so there was always a joke about when COVID kind of hit and everything shut down, that everyone's forecasting models were going to be incredibly off for that year. And again, want to ask what examples you've seen. And there's other areas of data and ML monitoring. So I mentioned explainability, but we have areas like model explainability and bias, checking to see if your model and data is biased. And then real quick, I wanted to pause. So today we're going to be mainly just looking at ML model monitoring and data monitoring, like the inputs and outputs and performance over time. But I'd love to do another workshop where we tackle more things like explainability and bias. What would you want to see another workshop on? And that could also, like, outside of just those two options, if you want to mention any other tools that you'd be interested in seeing, like ML monitoring with, maybe you want to see it used in computer vision, maybe you want to see with PyTorch, let me know in the chat. And I see a couple comments, so I'm going to catch up real quick. And then we're basically done with our slides here, and we're going to get on to the code. Someone said, this is probably in a response to data drift, is when a brand gets in the news and customers no longer want to buy them. That's pretty interesting. And they also said explainability and bias would be amazing. Awesome. Glad you think so. That's definitely on the roadmap. And we have some really cool tools that make it easier. Again, the links are in the comments or in the description. And if you do want to talk about explainability and bias, definitely you can message us on Slack. You could also book a demo if you want to kind of see if you have a business use case for it. You could definitely book a demo with, again, a link in the description as well. So getting set up, the only thing we'll want to do is open up that Google Colab notebook. Again, these links are in the description, but I'm going to post them individually in the chat as well. So this is going to open up a Google Colab, which I'll talk about in a second. And then the only other thing that you'll need to do is set up a free YLabs account. And then we should be good to go. So I'll give everyone a minute, but you should open up something like this, and then you'll want to hit File, Save, Copy in Drive. And then, again, if anyone wants to let me know in the chat if they did that or not, that'd be great as well. And I'll zoom in a little bit here. Hopefully you can see this well. So again, we want to open up the Google Colab link and go to Save a Copy in Drive. And then if you haven't already, sign up for the free YLabs account. And then some other useful links. So we'll be using YLogs, which kind of ties into YLabs. YLogs is the open source data logging library. You can go check out the GitHub here. And we always appreciate a star as well. So if you have a GitHub account and you want to give it a star, that'd be great. So I'll share that in the chat as well. And I'm in my copy as well because I'm going to be making some changes. All right, so a quick note on Google Colab. Google Colab is essentially Google's way of hosting a Jupyter notebook. If you've never used a Jupyter notebook before, it's a very popular tool to use as a data scientist or a machine learning engineer. It allows us to write code, documentation, and output all the visuals in one place. It's very useful. And again, you'll just want to follow along, hit Save a Copy in Drive. And then code cells. So here, go ahead and run this first code cell. You can run it by clicking this little play button, or when the cell is highlighted, you can hit Shift Enter, which is what I'm going to be doing a lot. So if you don't see me clicking on it, that's what I'm doing. I'm hitting Shift Enter. The first code cell will take a little bit to run because this is actually, when you run code here, it actually creates a whole like Ubuntu environment for you to run this notebook in. And so once the first one runs, everything should go pretty fast from now on. And then I'll just do a quick note. We don't need it for this workshop, but Google Colab is a really cool tool to get started with deep learning. And they give you a lot of free GPU time. So if you actually need it in the future, you can go to change runtime type and go to a GPU or a TPU. Again, we don't need to do it for this workshop, but I would just like to give a little shout out. All right, let's go ahead and start going through this code. So also, as I mentioned, this gives you kind of a whole Ubuntu instance, so you can actually run terminal commands by putting a little exclamation mark at the beginning. And we're going to use that to pip install a Python library. So Colab also comes pre-installed with a whole bunch of libraries. And what we want to do is install YLogs, though. So we're going to install this. Again, you can read more about this in the GitHub, and I'll talk about it in a little bit as well when we get to using it. But as a way of logging our data so that then we can monitor it later. And you can use, you can do a lot of cool stuff directly in your Python environment with it. So such as data quality validation, again, which we'll get to in a little bit. And we got an error here. Hopefully everything's going to be fine. So sometimes with Google Colab, you'll get some errors, and I think everything should be fine here, but we'll see. I just ran it not too long ago to make sure, and everything was good. So let's see what happens. All right, so we're gonna do a couple more imports. We're gonna import YLogs, NumPy, Pandas, datetime, and OS, and then we're gonna import train test split from scikit-learn. And then what we're gonna do is load in the Iris dataset. Now, don't worry though. Like I always like to mention, we're just going to train a model really quickly on the Iris dataset. We're not going to spend too much time on it, so don't freak out that, oh no, you've seen the Iris dataset model example maybe a million times at this point. I'm not sure. If you haven't and you're new to machine learning, you probably will see it a lot, but it's going to get way more interesting than just the normal Iris dataset in a minute. So first, we're just going to, again, bring in the dataset, and we can see the feature names. These are the names of those flowers, and then we have a sepal and petal length and width. And if you don't know, a sepal is kind of the under petal of a flower. And we're going to train a model very quickly. So again, if you haven't used sklearn or any machine learning before, don't worry. You can just run this code cell and everything should work fine. But I will walk through what's going on. We're importing neighbors, which is a type of machine learning model. We'll talk a little bit more about it in a second. And we're passing the hyperparameter 5. That just means that we're going to basically look at our data set. And then when we get a new piece of data, we're going to compare it to the closest 5 samples and then make a judgment call of like, okay, well, 3 of them are this class. We're going to classify it as that. We're going to create the feature and target data variables. So just I'm passing or I'm getting the data that we imported in and putting it in the X and Y variables. Then I'm going to use train test split. So I'm getting X train, X test, Y train, Y test. And then I'm using the train test split function. So I'm passing in X and Y. Again, those are just the data from the iris data set that we're going to train our model on. And then test size is 30% and random seeds 42. And then I'm going to stratify on Y. Stratify just means that we're basically going to try and get as even example samples across all the different classes as possible. And then we're going to train our model. So we pass in the X train and Y train variables, and then we're going to get our prediction here and just see that our score was 97%. So if you've never trained a machine learning model and you just ran this, congratulations, you trained your first machine learning model, which could be very exciting. But again, I won't spend too much time on this. If you have any questions, feel free to ask me about it later. But this is just to get a model trained very quickly that then we can start monitoring data as we pass through to it. And again, I mentioned KNN, just a very quick intuition on it. If you had a new piece of data come in, and in this case, if it had a neighbor value of 4, it's looking at the closest 4 other data points, and in this case, 3 of them are versicola, so it would predict that that new data belongs to versicola. All right, so let's go ahead and import some data batches. Basically, I just have some CSVs stored on GitHub, and we're going to import these in, and then we're going to treat them as if we're bringing them in more in a real-time situation. So right now, I'm just going to go ahead and bring them in and make these variables of like X data batch, and then I put them in a list here called DFs, and then we're going to loop through this list as if we're kind of looping through data more in a real-world scenario. So don't worry about this too much. It's basically just importing a whole bunch of CSVs, and then we're going to use those in a little bit to log. How's everyone doing so far? And if you want to look at it, the CSV, this is what it looks like. All right, so any questions so far? I'm going to keep going, but I always like to pause and ask if anyone has any questions. Leave them in the chat. Just make sure that the stream is going. All right, so create logs with ylogs. So ylogs is an open source library for logging data of almost any kind. With ylogs, users are able to generate summaries of their data sets. We call them ylog profiles, and they can be used to track changes in their data set, create data constraints to know whether the data looks like the way it should. We'll see this in a little bit, actually using it in the Python environment, and then quickly visualize key summary statistics about the data set and create some cool visualizations looking for data drift. So we're going to do a couple things with these profiles. Let's go ahead and generate one so we can kind of see what it looks like. And then we're going to use them in a few different ways here. And the profiles are incredibly efficient. So because they're just summaries of your data, they're not very, or they are very lightweight. They're customizable. There's a lot of custom metrics and stuff that you can do with them. And they're also mergeable. So if you're streaming data in, you can create profiles and actually merge these summaries together, which is really cool. I'm just going to go ahead and overwrite this pandas default. So we're going to display our max columns so we can see our profile. And creating a profile is very easy in ylogs. We're just going to pass in a data frame. So this is one of those data frames that we imported in before, or that we created with our CSV files. We're just going to call y.log. And we're going to create a new variable called profile1. And then we're going to create something called a profile view and then view it with pandas. So this is what's in our profile. We get several different things here. Cardinality estimate. So we can actually see that it estimates there's around 300 unique values in here. We get a whole bunch of distribution metrics. So like max, mean, medium, min, as well as all the different quantiles. And you get an estimate of different types. So is it a fractional? Is it integer? Are they objects? Are they strings? In this case, they're all pretty large fraction numbers. But there's a a whole bunch of different things you can do here. You can also use this on um, non numbers as well. So like things like strings and stuff would show up in here as well. So discrete and non-discrete values. And then using these, so you can see there's not a ton in here, right? Just all the stuff you basically need to track changes in your data over time. And so what's really cool is, again, like we were saying, this is super lightweight. It also doesn't have any of your really raw data in here. So some customers can use this as well in situations where like you don't want to transmit raw data. So like healthcare and finance industries tend to be a little bit more sensitive with things like that. And so actually using something like these data profiles is really useful in those use cases as well. And if you want to learn way more about Y-logs, which we will be going more into as well, check out the resources here. We have a ton of examples on our GitHub, and then also you can just go to the GitHub and then again give us a star if you think it's cool. All right, so like I mentioned, we're going to use these profiles in a few different ways. One, we are going to write them up to YLabs, which is an example of writing them to an observability store, kind of like we talked about. Like you're creating these profiles. Usually you're going to want to write them somewhere. That could be locally. You can use the profiles locally. You can write them to things like S3. You can also write them to our observability store called YLabs. So we're going to do that first, and then we're going to come back and use these profiles in a local environment for things like data quality validation and visualizing data drift. So I have a break in here. Also, there's a few code cells. So I'm going to be walking through this part, so you don't have to expand this, but you can expand these cells. Like if you want to come back to this notebook later and kind of see all the things I did, you're welcome to expand this and then kind of walk through it on your own. And then here's a code cell. It just has a break in it. So if you were to come back, or if you did go hit run all here, it would break because we want to update these environment variables here so that we can upload our data to YLogs or YLabs. So I'm going to go ahead and go to my YLabs account. Again, you should probably already have one by now if you're following along. If not, just go to ylabs.ai. I'll post in here. And you can hit login and create an account from there. I'm going to open up mine. And I have a couple things in here already. Yours should be blank. And what I want to do, and what you should do if you're following along, is create a project. Now, we want to set up our own custom model because we're actually going to go through all the steps of uploading our own data into here, which is really exciting. But if you do want to, you can later, like if you came back to this or you're not following along right now, you can add a little demo model here where we're going to upload some data just for you to poke around at. But it's way more exciting to actually use it on your own data and own models. So I definitely encourage you to follow along here and then go use this on a different data set. So let's go ahead and hit setup model. I'm going to give this a name. I'm just going to say workshop iris. You can name it whatever you want. And then we're going to go ahead and want to say this is going to be a classification model. We could leave this unknown for now and come back and edit it. That's no problem. But we know we're going to want to do classification performance metrics. So we'll hit classification and we'll hit create project. And then one important thing to note is your model ID that's created here. So mine is -33. Yours is probably going to be 1. I've created a fair amount of models in this environment before. So I'm going to go back to my notebook and I will update this part with my model ID. So again, mine is model-33. Yours will be something different. You'll just want to make sure that it's whatever number it gave you. And then we want to get our access token and our org ID. So once we have our model created, let's go to settings. Let's go to access tokens. And then you'll want to create a new one here. Again, I'll just call this workshop iris. You can set an expiration date on it. I'm just going to go ahead and create access token. It'll come up right here. Go ahead and hit copy. Go back to your notebook and then paste in your token there. And then your org ID is down here as well. So it says right here, and your org ID is always right here. So if you want to come back to it, always go to settings and access token. Your org ID will be there, and then you can set up a new access token as well. So I'm going to paste this in and then run this code cell. And if you didn't get any errors, you did it right. I will just mention sometimes copying over, it might accidentally add a space or a new line or something like that. Just make sure you don't have that. So there shouldn't be any spaces. It should just be these numbers that you're copying. Did anybody do this? Were they able to run the code and get the access token? I'll give everyone just a minute. I know. If anyone has any questions, too, let me know. Someone said, if you didn't copy the token, how can you see the token later? I believe that the token here, I think it even mentions that it'll disappear, but you can create a new token. So you can always just create a new token here. Someone said, yes, they ran it. Thank you. It's always good hearing feedback. All right, so go ahead and run the next code cell. So we're just going to import ylabs writer from ylabs. Again, you might get an error here. It's because we didn't, I think, install pill, which is a Python package for images. You can use ylogs for logging image data as well as most unstructured data, which is really cool. And I want to do a workshop on that. So like I mentioned, doing stuff with the computer vision before, I think it's really exciting. And yes, I did mention ylogs can be used on almost any type of data, and that does include unstructured data like images as well, which is cool. So let's go ahead and write a single profile. So if I run this code cell, we're using the ylabs writer. We're just creating a new variable here, initializing it, calling it writer. We're creating a profile. Again, this is how we create a profile, y.log. We're running it on our batch 1. And then writing it is just one extra line of code. So we're saying, writer.write, and then we're passing it the profile that was created, the profile view. And this is cool. So we're going to get a little bit more complicated in a second, but it doesn't need to be, mainly because we're backfilling because we don't have a real live data stream to run in this Colab notebook. And I just want to mention that this is very little code, right? Overall, just kind of 3 lines, a couple imports, and then basically 3 environment variables here. And if we go back to our ylabs account, we can see workshop iris. It has some profiles uploaded. We can tell that because we see some inputs here. What I like to do is typically click on this little shortcut. This is going to make sure that it brings up the date here. So you can manually adjust these dates. But if you go back and you click here, this is always going to adjust those dates to wherever the data is in your project. So if I go there, we can see input. We see there's no anomalies in range right now. And then we can go do things like investigate these. And we're going to do this more. We're going to upload more profiles because looking at one in here isn't that interesting. But I just want to mention, right, that was pretty easy to go ahead and create a profile and then upload it. So we're going to do here. This looks more complicated. Mainly because there's a lot of comments explaining it, but we're also just taking all those data frames that we made earlier, and we're just going to enumerate through them. And for each one, we're basically just going to add a date time to it and then send that profile to ylabs, just like we did above. So by default, ylogs will just assume the date time is the current date time, but you can add in the parameter of date time. And that's what we're going to do here is basically go through all those profiles and then subtract a day from each one. So we'll just be backfilling all those data frames that we created for, I think there's 6 or 7, so it'll be like 7 days backwards. So go ahead and run this. It might take just a few seconds. And then we'll go back to the ylabs platform. And I'll actually just go back home. And then you can actually see this date range change. So now it says from, October 6th to the 13th. It says the 13th, even though it's the 12th of my time zone, but it's counting from a UT time zone. So here we see that we can see a little bit more data. Like we see total count, just some summary statistics on this page. And we can go to profiles. This gives us a drop down with all the profiles here. We can actually do things from this screen as well, such as compare profiles together. So let's go ahead and add a couple. This is a little bit of a spoiler maybe. Oh, no, okay. So sometimes I'll select these profiles have errors in them on purpose so we can see how to monitor for them. Oh, no. And sometimes I select those. Oh yeah, so you can see actually the distribution of this top one is way different. Let's get a more normal looking one. So you can actually go ahead and add several profiles. You can do up to 3 here and kind of compare them, which is pretty cool. So you can see like how those distributions kind of look between each other. And we can actually see just by visually looking at this that there might be some changes between these profiles. You can view more data and kind of get a cool breakdown and even change the bin of the distributions. But I think the more exciting part, at least to me, is I can go to this input tab. That's where we have our 4 features. So we have the length and width values for our petal and sepal. And then we can go in and we can see, so we haven't set up any alerts yet or anything, but just by looking at this data, does anyone think there's some sort of anomaly happening? So if we just kind of scan it and hover over it, you'll actually get some data. We can see that there's like a max, min, medium, all those kind of statistics that were in our YLogs profile now up in here. So dragging over our by each date, we can see some summaries of our data. And we can tell that if we go over, like the max for these is about 6 something, right? Almost 7. And then if we go here, now the max is 11. The medium went up quite a bit. The medium was around 4, and now it's around 8. And then if we go over to the next profile, the medium's over 100. And then if we go to the next one, the median is 0. And then it kind of resumes back to the 4 range. So does anyone think that that would potentially be some sort of error in our data? It changed quite a bit, right? So if we were expecting our data medium to be around 4 for most of the things, and then all of a sudden it spiked way up to 100, that means there's probably some big change in, again, one of those things that we mentioned. It could be like sensors. It could be some sort of pre-processing error. All right, so this is cool for us to manually look at, but we don't really always want to manually look at our data, right? We'd much rather have some sort of alert trigger when some sort of error happens. So the point of this is we can set it up and constantly be logging our data, and then we hopefully don't have to worry as much about it because we expect it to throw an error when something bad happens. Like we don't have to constantly be looking at it. But we can if we want to visually come in. So you can hit this button. We can say set up monitors, or you can go to this monitor manager tab right here. This has some really common or really cool, commonly kind of preset tasks for monitoring data. So such as data drift in model inputs, all discrete values, all non-discrete values. You can also look at things like data quality. Like if there's unique values, missing values, the data type is changing, percentage change, unique values, and then model performance. So we'll log performance in a minute, but we can measure the performance and then get some sort of alert based on that as well. And then we have a lot more coming in presets. And then just to mention that, if you don't see what you're looking for in the preset here, you can actually do, you'll see when I set this up. First, I'm going to enable one just with one click. This is going to be looking at our non-discrete inputs, and then basically just compared to a 7-day baseline. So I could go to this config investigator, and actually this is where I can change it to be pretty much anything we want. So if you don't see something in a preset right now, you can manually create it here. But now that we've enabled this with one click, let's go ahead and go back to our inputs. And we can come back to the configuration in a second. Let's go back to one of the features, in this case, the petal length. And let's hit preview now. So you should have this little preview now button here. And by default, the monitor runs every 24 hours. So you would get an alert like we'll see here, except for it'll just run on its own. So we can look at this preview and see, remember, we were looking at those values and seeing how much they changed in those 3 places. And we can actually see that those alerts were caught here, right? The medium change from 8 to 100 to 0. These are all automatically triggered here just from us enabling the default monitor, which is just kind of saying, basically, it's looking at the data profile and looking before it and saying, was there a big change over time from that rolling window? There's other ways of setting up as well. So you can actually set up a comparison profile. So instead of looking at a rolling window over time and seeing it change, you could have a static profile. and just compare to that. So that could be like your validation data set or something to say when something goes way out of this distribution, let us know. So let's go back to the monitor manager real quick. You'll see the monitor here that we set up. We can edit it from here. You'll see an anomaly feed. This is where everything will show up when it triggers. Go back and look at presets. You can also take one of these presets and then go to configure. And this will just give you more options. Basically, it's a good starter one. And then you can edit, what you want in here as well. So like one thing that people might want to edit is the Hellinger distance. So that's what we use to calculate how far the data has drifted. There's different distance type things you can use for that. We use Hellinger distance, and then you could lower it or raise it up here. And then you could compare it to a trailing window. Maybe it's 7 days, 60 days, 90 days, or you can reference a date range, or you could upload a reference profile for it. Real quick before we get back to some of the code, and I'll ask if there's any questions. You can also go to settings, go to notifications and digest settings, and then you can email here and enable this or disable it, and so that will send an email. It's really easy to just cool. If something goes wrong, send me an email. You can also set up a Slack integration. You can also use PagerDuty for an integration. So if you actually want to do some triggering in your pipelines, PagerDuty is probably the way to go right now. But it's very easy. I use emails all the time for my personal projects right now. And then if something does go wrong, like there's a big drift in data or it goes really dark for one of my computer vision cameras or something like that, it'll send me an email, which is pretty neat. Any questions so far? I keep accidentally hitting back with my trackpad. Did anyone run this? Did anyone have a project? Are they monitoring real data right now? You also have a summary tab, so there's not much in here yet because we haven't set up the performance and it hasn't done a full trigger. But this is kind of cool. You'll see a neat little summary of everything going on with your project as well. Someone said, yes, they ran it. Awesome. All right, so this is just for input data. Now, you can upload any data in your input section here. But we do have a breakout tab for output. Right now, because our model is pretty simple and our data is pretty simple, we only have 4 features, so it wouldn't be insane if we just logged output data here as well. But a lot of times you might have hundreds of features, and it gets really hard to find your model outputs in with all of your input features. So we have a separate tab for outputs that you can log to, and we're going to go ahead and go back to our notebook and log there next. And because I mentioned doing the reference profile, again, you can read more in the YLogs documentation, but I did include this here so you could uncomment this and then write a static profile and then compare to that for your monitor as well if you wanted. Again, there's some stuff about or images, so if you're going to come back to this later, you can expand this and kind of see all the images that we went through, or that I went through showing the observability stuff. All right, so logging output, I'll just go ahead and run this. Basically, we're taking those, or we're taking the data frames that I can actually run predictions on, and then for data frame, we're going to enumerate through, and then we're basically just going to run that KNN model that we created earlier on each data frame. We're going to store the probability scores and the classes, and then we're basically just going to write that to the existing data frames that we have. So if we look at this data frame, we can see now that there's our input features, our length and width of our petals and sepals, and then we'll also see the class, and we'll see the probability output. So this is class 0, and I was very confident that was going to be class 0. So basically now we're going to do the same thing we did above, where we enumerated through and then wrote them to YLabs, except we're doing it now with our new data frame. Or instead of the whole data frame, we're actually just doing it for the class output and probability output. But I will note that you can do it. If I was actually doing this on a model I already had running, and I wasn't doing the logging in multiple parts of my pipeline, I would actually just log these at once. So if I had access to this data frame and then the model output, I can combine them here and then just write them incredibly easily like we did with those 3 lines of code. So I just wanted to break it out for the workshop, though, because I think it makes a little bit more sense to flow this way. So if we refresh here, we'll now have outputs, and this is just very similar to like what we've seen in the input one. It's just that it's a way of segregating out so you can more easily find your outputs versus your inputs. So to go back to our notebook, let's go ahead and log performance. And then let's look at our data frame again. We're just going to go ahead and take some ground truth. This ground truth was in when we imported those data frames. There were several that had ground truth labels in there. The ground truth just means that we know what that that data belonged to, or what class that data belonged to. So in this case, we had these features. We had the class output. That's the predicted output, our probability output, and then I have a new column now for ground truth. And then we're going to log that very similar to like we did before, except we use this whiteout_logs classification metrics, and then we want to pass in the data frame. We pass in which column is the ground truth and which one is the prediction class and which one is the probability score. And then this is just, again, enumerating through and subtracting a day for each profile. So now if we go to Performance tab, you can see that we're logging performance over time. So we can also set monitors for this. So someone had mentioned that they had heard of teams like relabeling and training just consistently, which is crazy. But if you are relabeling and retraining your model, you will want to monitor the performance over time too. So if you're getting that ground truth data, you can log that in here and kind of see how well your model's been doing over time, which is cool. You will see this other tab segments. We're not going to go into this today, but this is a way where we can do some things like bias and explainability like we had talked about, which is exciting. Any questions so far? We're going to go on and get a little bit more into Y-logs next and do some stuff in the local environment. And don't forget, if you think you'll have questions later, I definitely recommend joining the Slack channel. So I usually have a lot of people after workshops message me on LinkedIn or the Slack channel. Both of those places are good for me to reach me. And I'll just mention again, you go to Monitor Manager, and we could take one of those presets and look at our model performance and enable one of these, and then if it dropped a lot, we would get an error or get an anomaly detection. All right, cool. I'm going to go a little bit faster because I know we're almost at 6:30, and I see some people dropping. We went through, I think, some of the coolest parts of like going through using a whole platform where you can actually kind of put throughout your entire pipeline now. But let's go ahead and go on to Y-logs and using it in a Python environment. So we're going to use Y-logs for data quality validation with something called constraints. Basically, we want to look at the data and ensure that it is structured the way we think it should be structured, or that it falls into those ranges that we think it should fall into. So when we saw that giant jump in our data in Y-labs, right, like going from a max of 8 to 100, that's a pretty big jump. And if we're actually taking that data and using on a model, like we would know we probably wouldn't get the correct prediction. So what you can do is use something called constraints and actually look to make sure that that data is actually going to fall within the ranges that we want. And that's what we're going to do now. So we're going to go ahead and just create several different profiles with Y-logs. Again, these are all those batches that we imported earlier. Just to make it easier, we're just going to do it in one cell here, and then we can call these different numbers. And I encourage you as we go, because I'll have some pre-written stuff here, to change these numbers. So if you want to see what the constraints look like on different profiles, just swap these numbers out from 1 to 8. So let's go ahead and look at a profile again. So we can see that if we go to our distributions and we look at the max value, we can see that these are the max values for each of the feature. Now it has the ground truth and output in here as well. But so, for example, we could say, well, if we know that a petal length isn't going to go above 10 or something like that, we could add a constraint to say, to check for that. So let's go ahead and import constraints. And we're just going to build one here, and then we're going to use multiple ones in a second. Basically, we're just going to initialize our constraint builder. We're going to add a metric constraint. So in this case, we just give it a name. This can be a string of anything you want. I typically kind of write out the formula that I'm thinking in my head that I want to implement. So string type is equal to 0. This is saying that, everything should be a number and there shouldn't be any strings in our data. If there is a string, it should let us know by failing. Basically, you're writing like a little unit test for your data and saying, the string type should equal to 0. If it's not, throw some sort of failure alert or anomaly detection. And then we're using a lambda function basically, and what we're going to do is pass in a couple of values to our metric selector. And what we're saying is we want to look at types, and we want to look at this column petal length, and we want to say that the string.value is equal to 0. So if we go back to our profile, we can see each one of these kind of columns start with something like cardinality, counts. If we scroll all the way here, we can see that there's types, and we can see that there's a types string. So when we say dot string, that's what we're saying. We're looking at the types metric, and we're saying string is equal to 0. So we go ahead and run this. We'll get this little text report here. We can see the string that we wrote initially, saying string type equals 0, and then we get this 0 and 1. And the way to read this is, again, that's the name that we gave it. It could be any string. And then the middle one is pass, and then the one to the right is fail. So in this case, it's saying that this failed. And we'll see a little bit more of a pretty way to look at this in a second. But let's go ahead and do multiple constraints. So we're basically just doing the thing we did above, but 4 different times, and adding them all to this constraint builder. So we're just looking at the petal and sepal length and width, and we're going to say that I actually think I updated this, and I say that they're less than 8, but we're actually saying that they're less than 15. So if they go above the 15 or below 0, it should say that our data didn't pass the test that we wrote for it. And we get this kind of long report, right? This is kind of harder to read, even though we know that this one in the middle, that means it failed, but there's a lot going on here, and we could have way more than 4. So what's a cooler way to visualize that is use our visualization. And you get this little report like this, where you can actually even do things like filter and search. So if you had way more than 4, you might want to look at all the failed or the pass constraints. So this gives us a pretty little report here that we can use to visualize what's going on with our data. And then maybe something more useful for ML pipelines or automation is you can use this validator where we're saying basically all of our constraints passed or failed, and then give us a value of true or false. So in this case, they all passed, so it says true. So I can write all those validations, and then I could run my data set through it and say, does this pass or fail? And if it passes, do something. If it fails, do something else. So let's do this again. We're going to call it on a different profile. So this is what I was saying. You could change this number around if you want to see what different profiles look like with our constraints. And I think I said the middle one meant fail before, but I meant that one means pass. Uh-oh. I lost my runtime, I think. Come on, Google Colab, don't fail me now. All right. Occasionally, Google Colab will disconnect or something. It's a great tool, but I got worried there. All right, so we ran that, and we could see that all these failed. And then we could do the same things. So, right, we could run on all. Did they all fail? Yes. And then we could actually look at our profile and see why. This one looks weird. We can already tell the cardinality looks different. It says there's only one unique value. And if we look at the all these numbers, the mean, the medium, the min, the max, there is just zeros. And this is a profile full of zeros. And all right, so you can learn way more about the constraints here on GitHub, how to validate, or there's a blog post here, and then also there's just really good examples on GitHub. And we have another feature where you can do conditional count metrics, where instead of just using the metrics in our profile like we saw here, you can actually look for more specific values using regex. So if you want to look for like email addresses or something that you might think is like personal information that shouldn't be in your data set, you can use the constraints to look for that as well. All right, so I'm going to go on, and we'll just have one more thing to cover real quick. We're going to use ylogs to visualize data drift in our Python environment. So again, I'm going to go pretty fast because we're right at the 6:30. We're going to import notebook profile visualizer. We're going to initialize it, call it a visualization, and then we're going to say visualization.profile. We've already passed it in just the profile one. We can get some statistics here that you can look at, like missing, mean, value, max, just kind of a better way of visualizing it and seeing kind of where the distribution is. But what's more fun is, just keep going, is doing the summary drift report. This is basically on these two profiles. So I pass it in profile 1 and profile 2. And now we can see kind of how their distributions look and what the p-value of the drift distance is. So basically, the higher this value, the better. If it's a 1 or close to 1, it's basically saying that the data is very similar to each other. And if it's really low, then it means that they're pretty far apart. So in this case, a cool way of visualizing that as well is you can use this histogram feature and kind of plot where those distributions lie. So looking at these two profiles, we can see that the petal width distribution is very similar to each other. Yeah, there's like a little bit more here, but that's why it's such a high number. There's almost no change in distribution. If you look at this one, basically the same. So let's load in a different profile. We're going to use profile 1 again and then compare it on profile 6. Do our drift report. And we can see that our values are very small or calculated at 0. So that means there's quite a bit of drift, probably not a lot of overlap. And if we visualize the same thing, such as the sepal width, we can actually see that like there's no overlapping of those values. So one of them is way over there. That's the one that went from when we were looking at Y-labs, it was like the median of 4 to the median of 8 or something like that. So we can see that there's quite a big distribution drift. And again, in the notebook here, there's a lot of links that link to learn way more. So there's 5 ways to inspect data and models with ylogs profile visualizer and the notebook profile visualizer example if you want to learn way more. And then conclusion. So we covered quite a lot in a pretty short amount of time, including creating data profiles, sending those data profiles to the tool like YLabs, and then also using them in several different ways in our Python environment here. Hopefully you found this useful. Let me know in the chat if you feel like you learned something new. Is it cool? Are you excited to use it in a project? Are you going to start implementing AI observability into your projects if you've never done that before? And then what's next? Join our machine learning Slack channel to ask questions. So if you have any questions, if you're going to be using this tool or just about AI and machine learning in general, it's a great Slack to join and share those questions, as well as just share anything else cool in the industry that you see. And then again, I think I asked this a couple times, but what type of workshop would you want to see next? And if you have any specific tools in mind, let me know, because that'll be something I'm working on. And let me see if I can copy this correctly in the chat. Oh, cool. I see some questions, and I see Andy already answering them. Thank you, Andy. Let me see if there's anything else I missed in the chat. And there's still people here. So someone said, thank you. That was awesome. Thank you so much. Yeah, thank you, everyone, for coming. Again, links to everything is in the description below. So there's links to the Colab notebook if you want to come back to it. The recording's also going to be at the same URL. So if you want to come back and rewind this workshop at all, you can do so there. Let me just make sure everything is wrapping up. But that is all the planned content I have. So if you have any other questions, feel free to put in the chat. Or, like I said, join the Slack channel or find me on LinkedIn and ask me questions there. Yeah, and it looks like Andy answered any of the other questions about the drift reports. Cool. I think I'm going to go ahead and probably end the stream, everyone. Thank you so much for joining. And if you have any questions, find me in any of those places I mentioned. And hopefully I'll see you all at a different type of event or workshop in the near future.